Yeah, we talk now about another topic of vertical integration from the lower layer of IO-Link to the upper layers. And now about OPC UA. Somewhere here has to be the pointer. And I want to give you in my presentation two parts. One is the technical part, what is OPC UA and what is OPC UA for IO-Link, and a more organizational part about the current status of our specification and what's our next step. The next step is doing a test specification. Now, what is OPC UA? Let's talk with a picture of Matthias Damm, one of the so-called gods of OPC UA. He said before OPC UA, the communication of machines with each other was blocked because of different languages and primitive communication. But when you introduce the OPC UA communication and its powerful information models, you will get a very clear and vivid communication between the machines, especially because of the information model, which adds semantics and makes it possible to that machines talk with each other without knowing them before. Some said OPC means Old Programmers Club, but it was an acronym for OLE, for process control, but it was never based on the OLE technology. It was based on DCOM at the beginning, which was a Windows technology, and I think somewhere in the range of 2006 also, they made a shift to OPC UA, which means unified architecture, where they bound a set of specifications together. And OPC UA has usually in the past a server and a client, and but nowadays they brought out also other things like PubSub, where they break out from the client and server model. OPC UA is a TCP-based protocol, and therefore, unless not like OPC, it is platform independent. The object model is object-oriented and very flexible. One of the key parts that is regarded by the BSI, Bundesministerium für Sicherheit und Information, is that it has a very good integration of security mechanisms. There is written like you can set up a PKI infrastructure to have secure transport. And OPC UA is scalable from sensors to cloud. There are profiles which make it possible to have very less communication partners and a little information model, and others are blown up to store gigabytes of data. If you want to give a short overview of three things how you could describe OPC UA, I would mention first the very powerful concept of information modeling of OPC UA, having types and instances and stuff like that. Then a set of services to operate with this information model, to read the values, to write the values, to add nodes, to delete nodes, and stuff like that. And third, a set of protocols. The most common protocol of OPC UA is the OPC UA binary, but transported in client-server manner, but they also released one which is in publisher-subscriber manner. I do not have the time to go in greater detail, so I come to my next point. OPC UA for IO-Link, what's that? At first we can see the IO-Link topology on this slide. At the bottom we have the devices. Above of it we have the masters, and above of it the higher level IP devices. And you can have an OPC UA server on for example, a PLC that has attached IO-Link master modules. You can have it directly on a master. Maybe this is a field bus gateway or even no field bus gateway. And you can also use a proprietary protocol to communicate with the IO-Link master and have your server somewhere else in the space. In this picture, the PLC is now equipped with an Ethernet switch, so it is just a normal Ethernet connection between it. Yeah. Which functionalities are built in OPC-UA? All the things that are in the SMI and a little bit more. So we have the discovery and identification of IO-Link masters and IO-Link devices. We have options to configure the IP settings on the master or the gateway, and also the ports and devices settings. Port configuration belongs into this. And of course, data transmission, reading and writing, process data, and IO-Link parameters. Then alarms and events, giving the diagnostic information from IO-Link masters, ports, and devices. Statistics, connection stability, device change detection. We did not know about measuring of output values, as the presentation of Hilscher said this morning. Then the firmware update. This is something we wanted to realize, but we did not manage to do it in the first release because of specification dependency restrictions. The OPC-UA for devices specification is currently reworked, and they want to introduce a mechanism for firmware update, and therefore we waited for our next release to introduce this. And then the IODD handling. In most of the mappings that we have heard before, IODD is not really concerned in the transport and has to be added on the client side, but the master makes the OPC-UA mapping also introduces the IODD handling on the master side to have a more enhanced data modeling, and OPC-UA is predestined to be used for values with more semantics, for example, the engineering unit and stuff like that. Then you can, of course, realize upper level use cases like asset management, condition monitoring, rule engines and logic, and configuration backup and restore, and those kinds. I go over this a little bit more fast because it's not related to the mapping directly. Yeah, we made a specification document. The OPC-UA, the OPC Foundation and the IO-Link Consortium, they made a joint venture, and a companion specification which belongs to, I think, both of them. And the information model has 3 major parts. The major parts are an IO-Link master type, an IO-Link port, and an IO-Link device. And this IO-Link device is split up in different types. You can have a simple type, which is without the interpretation of the IODD, and a more advanced one, the IO-Link IODD device type, which contains the interpretation of the IODD. And this is small on purpose. I just want to show you the overview, which is very clear. We have on the left side a master, and there is an object port. If you browse this object port, you get all of this. And in this port, we have connected a device or more devices. And if you browse this, you come to the modeling of the device. Yeah, doing a mapping of the IODD is always a little bit tricky because of the great complexity of the IODD. And so we had several obstacles doing this, but the flexibility of the object model of OPC-UA made it possible to do it. And so we can model everything that is in the IODD and that is necessary to be transported. What are the benefits of OPC-UA for IO-Link? You do not need the field bus. In this case, you do not have to buy a PLC, which reduces your installation costs. You have more information available out of the box, which means you have less integration costs to get your information. And it's no vendor-specific way of accessing the IO-Link devices like before. And you have, of course, the general advantages of OPC-UA, like the very flexible information model, the way to deal with the data to transport it to a higher level, to use it in other systems, and so on. So I want to encourage you to support OPC-UA for IO-Link in your devices. I was very lucky to hear that others are also pleased of the technology, as I heard in the presentation of Hilja this morning. Yeah. Now to the organizational part of my presentation. The current status of the presentation is one slide, describing the different stages of an OPC-UA companion specification. The document has to be released, a node set has to be available, and the review has to be finished, and this is done, therefore it is green. Then we have to prove interoperability with at least 2 reference implementations, and we have to do a plugfest. That's not done yet, but we are working on it. And the third thing is the certification. To make a certification, we need a test specification. And then the products can be certified in an OPC test lab. And we cannot influence as a specification body the part number 2, but we can influence the part number 3 by providing a test specification. And because of that, this is the thing we are doing next, providing the test specification. An OPC-UA test specification consists of merely 2 artifacts. One is test case definitions in an Excel sheet. So it's not a Word specification, but simply a predefined, pre-structured Excel sheet. And we have to provide test scripts for a software called Conformance Test Tool, where the OPC Foundation tests the conformity to the tests that are defined over here for a product. Yeah. We started recently, or restarted, the OPC-UA for IO-Link integration group and had a kickoff meeting on 7th of June. And our next goal is to have a test concept defined at first. And if we have this test concept defined, we can specify the test cases. After that, we have to do a little bug fix on the companion specification. We know this already, because it depends on conformance units for those who are acquainted with OPC-UA conformance specifications. And then we can publish our test spec relying on this and hope to get the test lab finally operational. Yeah. Our next actions, the next action in time is a web meeting on 12th of July. And we ask for more working group participants. At the moment we are a very small group, but we need some more participants to get the expertise from the implementers. What are the crucial things we should test? And I can say I learned a lot in going to specification working group meetings, because all the crucial things, the things that are not clearly specified in the specifications, they are discussed there, and so you can get pretty good knowledge. And last but not least, we need some budget in 2020 to develop those test scripts. And yeah, just as a pre-remark. Yeah. Thank you for listening. If you have any comments, questions, or remarks, I am open.
Okay, so the second part for vertical integration. So OPC UA is really nice, heavy in functionality, much functionality, but takes, I assume, also some resources on the microcontrollers as well. But there is another integration path, vertical integration, I want to show you, and this is called JSON, or people say this, so JSON. The JSON integration, and I want to give you a short introduction about the activities and as well as use cases, starting with use cases here, not going too deep into technical things, but keep in mind JSON could be something like the little sister of OPC UA, which means it's smaller, it's leaner, it's not that powerful, but maybe it's fitting into applications. So think about an application. Somebody wants to measure the snow height maybe in the Swiss Alps. There is no PLC around, there's no field bus around, and there is no, let's say, high bandwidth network around. So typically some snow height values are published, let's say each 10 minutes or something like that. And there is a technology available which is called MQTT. Well known in the market, and well, the thing is, or the application is, the weather forecast service needs actual information, but it's not willing to pull each millisecond the value of an analog sensor. No PLC, no field bus available, and we need seamless and easy integration, let's say, into the IT world. Could be clouds, could be something different, but that is data flow in the IT world is required. And just as an example, you see here the temperature on the lower left, which is minus 2.5 degrees. It goes over the IO-Link wire to the IO-Link master. And there in the master we have a data server, in this case an MQTT publishing client. And what this guy is doing, he is transferring let's say the process data of IO-Link into a JSON object. And a JSON object you see here is clearly readable also for humans. And this JSON object goes to an MQTT broker. Afterwards, the connection is, I want to say, interrupted, no other actions. The value is now in the broker, and any clients can do an abonnement or subscribe to these values and get the new value, and this is the pub subservice, also mentioned before by Mr. Stills, will be introduced also with the OPC UA, but this is the lean version, and it's called MQTT. So, and what the IO-Link guys are doing is standardizing this part. Not the MQTT, but the content. How is it accessed, how is it published, and so on. And this is called in JSON. JSON is an abbreviation for JavaScript object notation, well known in the IT world as well. Okay, so if we do so, it's clear that we have to implement this publisher in the IO-Link master. And here you see a picture of the model we have, and we have one that I call a compact model. Other people say IP67 models. And we have modular models, which different IO-Link masters, but here as well as here we have this MQTT client, which is a publisher client. And what we have to do is to bring information, configuration information to this piece of software, telling where to publish the so-called topics, which is the information, and what are the topics itself. So we need some HTTP methods for the client, and these are the clients. Configuration, you see here, get and set configuration, and get and set topics. And the topics we want to publish, in the example it was the temperature, could be process data all the events of the IO-Link device, or maybe the event of an IO-Link port. So that's the story behind. And what we need and what we want to do standardizing is the configuration of such an MQTT publisher. If we do so, then we are free to have here the publisher inside the IO-Link master and can go over any network to the broker and to another client, which could be a smartphone, a cloud service, everything you can do. And therefore, the IO-Link community decided to do a standard for an MQTT client configuration via a REST API. So we get a REST API for configuration of MQTT publisher, easily spoken. But there is a different thing. So MQTT is one thing, but what about the classical request-response communication we all know from automational system? So there is another thing, and therefore also with JSON coded, we defined a REST API for data access, going that way that a client can do a request, maybe over TCP/IP or something like that, and gets at the end a response. That's also the way IO-Link works. Huh? Master gets a request and gets a response back. So again, we defined for this, I want to say game, RESTful web services based on HTTP methods. Well known in the IT world, these are the GET, the POST, the DELETE, and whatever. And the data which are transmitted are serialized or coded as JSON object in a clearly standardized way. And that's the task we did in our specification work. And if you look, here is an example which looks, reading the port status, maybe this port, if this is the request, the response looks like that in a very clear way as a valid JSON object, which can be decoded, I think, in nearly each software in the world. Even browsers can, with one line of code, decode JSON objects. Okay, and the data model we had behind is, again, we had the compact model and the modular model. But we have, as you know, we have the gateway itself, then we had the master, then we had the port, then we had the device. And related to this model, we have defined access levels. Access levels and these are parts of URLs, /gateway, /masters, /devices, and do I see the ports? And regarding to the addressing level of that, we have some data and data clusters. We can cluster something like what the status, the identification, configuration, process data, and what's new capabilities. So think about an HTTP client can ask an IO-Link port, what is your capability about power providing? The specification now says we can more have than 200 milliamps, but it could be interesting not to read it in a data sheet, but out of or online via a request, what are the capabilities of the power supply of an IO-Link master? So that is a new part we added here. And here you see on the right side just an example. A request could look like this, and if you are familiar with URLs and typing in the browser command lines, HTTP, something, you see this is very the same. So we get access via IO-Link version 1 devices, named by a sensor. And at the end, we want to read here the index 25, sub-index 3, and the value of that. And back comes, for example, threshold 139, something like that. Very easily also to track with some sniffer tools or if you want. Okay, so this is what we've done. And what are the technical features of the JSON mapping document? So first of all, we have data access to these things like process data, capability, status identification, and so on. We can have something very nice, which is addressing. So think about addressing of a device. Today, you have to know the device is on port, let's say 3 of master 2. So we can now give the device a name, a spoken name, like temperature sensor, and can have access to this device by name. So in the former example, we want to read something like master port index. Now we can say, please give me the temperature of the device name of the temperature sensor. So this is something very nice. And we can also have access by the parameters by IODD support. Not only by index 25 subindex 3, but by the name of the index, which means the IO-Link master will also contain or has to contain an IODD interpretation. Well, another nice feature is topology. So scanning of topology is possible because you can ask a master how many ports do you have, which are the devices, where are the devices, and so on. So also this is possible for modular as well as for compact models as well as for modular models, which are usually called remote IOs. And some features. One is the feature for IODD support, so that the name resolution can be done. It's optional. And the other one, I talked before, the MQTT publishing thing is also optional. But if everything is defined to access and run this MQTT publisher and the configuration. And added at the end, some added other functionalities like reading the event log. You know, IO-Link is producing events. This can go to the event log and you can have, via this JSON interface, access to these events. And also data storage transfer, which means data storage, which is on the master port, can be read and stored anyway, and can be restored also via this JSON interface. Okay, so the specification is not released yet, but nearly finished, I guess. With the end of July, we will be ready to go in a review, which means we can release this one in, let's say, third quarter, fourth quarter of this year. And it provides I want to say lean and standardized connection between IO-Link and the IT world. For easy applications without PLC and field bus, and you have global access to all measuring data and parameters, and of course, therefore, a seamless integration or a data connection also to ERP world, MSE world, and so on. And what you also can do, you can configure the master and devices. This is, I want to say, the engineering part. So today we have engineering tools for configuring master and ports. Now we have a standardized way to do this, or in a standardized ways. So all the commands of this JSON are prepared to do this as well. Okay, so I want to say with the JSON HTTP interface, IO-Link gets more universal and smart and easy. And that is our claim we have. And, well, that's the end of my presentation so far. Thank you.